Previously on The Bald Engineer.
So RJ says his favorite component is a spacebar because you can indent. If I got a good angle. Oh yeah, that's some good stuff there, right? Okay, get this go. Whoa, 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 whoa. These are a heck of a lot better than what I was thinking. Jeez. I know how to use a computer. I do. Okay, there we go. So that's why you shouldn't drink while you do this stuff. Huh. Anyway, moving on. I want to be very clear. So I'm going to put the heat inserts into the hardware box. So if somebody could please clip this so I know that the 3D inserts are in the hardware box. That way I can find them next time. So, okay, I've got another idea. Anyway, but there we go. All right, that's what I was trying to get to. Oh, goodness. And live. Hello there. I'm James, you're you. Let's have some fun. Welcome to the stream. Lead vitamin. Yes, KeyCat is good to know. I would actually say any EDA is good to know, but I just feel like KeyCat is one that unless you need a field solver or some really extreme RF stuff, it's a good one to have in your back pocket. Hey Marion, good to see you. All right, so Alex, sounds like you're at the bottom of the ocean. Why? Let's see. I don't think this should be it. I'm going to try this. And then I'm going to double check. Let's see. Common elements. Input mic. Yep. Okay. That's why. Okay. How about now? Yeah. I don't know how that happened. No, wait. That's not right at all. Huh. Uh-huh. All right, well, number one, that was the wrong thing to do anyway. And then filters. This suppression is okay. All right, and then I'm going to do, I've been talking now, so I can move, fast forward this, and then I can hear what I'm hearing. Yeah, that's really bad. I think maybe I'm going to try turning this off. I think I have way too much gain going on, and so we're peaking it. course, now I can't hear I can't hear myself, but we'll see. And then after this is the best I can do. Of course, now I can't hear I can't hear myself, but yeah, we'll see. Yeah, we're just gonna have to go with it. That's the best I can do. I didn't change anything, so I don't know why it's messed up. Yeah. The other thing okay, I will try one more thing and then I'll get going. Let me shut this off and see if that helps. Okie dokie. Let's see. I do actually kind of want to hear what it sounds like now because I'm mad because I did all these tests a while ago. So yeah, it seems like that's a lot better. Okay. All right. Sorry. One day I'll make audio work. I'm really mad because I went through all this already. So yeah, I mean, what's weird is I did testing. I wish you told me last time because I would have fixed it. I did testing and I liked the way it sounded, but the way it sounds now is not how my testing sounded. It still is part of the fix. Anyway, doesn't matter. Okay, let's do some. Okay, I wasted too much time with that. Let's do some KiCad. Yeah. I do want to check one more thing. Okay. I just thought of this. I should have turned the gain back on. I have an equalizer stage that's causing problems. And so that's the root of the problem. Okay. Okie dokie. Now, so we're working on this project. It's called a state mode logic analyzer. It's going to be based on the new RP2350. However, the first thing we're going to do before we get over to the PCB is we're going to replace the discrete RP2350 with a solder party XL board. Basically, I'm not sure if I say his name right, but Arturo, he makes a something called a stamp with RP2040s and now with the 2350, and I just want to make use of his board. So we're just going to go and replace that. So I think what I want to do, I just committed this already so that I can come in and we're just going to say, I am going to save the pins because I want to remember what we had decided we're going to use. But everything else, we're going to say bye-bye. So bye, bye, bye. I don't think we even need the power, but I'm going to hold on to that for just a second. And so now we're going to add a stamp XL. Maybe. What did he call it? Did I not include the library? Symbol libraries, project specific. Oh, you know what? I might have moved this. I might have moved it. No. Oh, yeah, no. Yeah. Oh. That is exactly what's going on. Is I need to get the where did I download his file? LP footprints main 7-zip extract. It already contains this folder. So where is RP, this one? And then I need to go put that into the KiCad folder that I have. How's everybody doing tonight? Anybody working on anything fun? Did you know KiCad 8.3.5 is out, which is actually a surprise to me. I didn't realize I missed 2 minor revisions. Well, I guess I missed 1 minor revision because I was on 8.03. Where is download it libraries? And make sure it's not here already. Okay. Then we're going to go to this folder because I want to go to there. Copy address as text. Okay. So now over here, we can add a folder. And I'm going to type in this path. We're going to go into KiCad, RP2040 stamp symbol. All right. And I want to make sure that the stamp I want is in here. So now let's find that. Yep, I want the stamp XL. Why is there two? What is this? RP2350 stamp A and B. Oh, I see what he did. Okay. Okay, cool. So we'll do that. Ah, darn it. Something cool just happened. So I'm going to hit A to go back to add. I'm filter on stamp. And since this is multi-unit, when you A will go down and then B goes down. So multi-unit, it looks like he did it as multi-unit just because there's so many IO pins. Designing an electric motor, a motor controller, or are you making PCB inductors? Yeah, actually, I feel like after the 0.1 release of KiCad, you can, unless you run into a problem, it's not super critical to keep updating. But I do feel like the 0.1 is always like, it's probably not a bad idea to wait for that one, since so many people don't do the release candidates, which, I get it, but still. Anyway, what was I going to do? Axial flux. Yeah, okay. That'll be fun. Now that I've placed this, we need to go make sure the footprints are available. So let's go to back here, go to manage footprints, project specific. We're going to add this. I'm going to go to that same directory, going to go to the KiCad, and we're going to go into pretty, or wait, do I just select pretty? Yeah, I think I do. Oh, okay, that is what I had already done. Ah, I see what's going on here. All right. Really? All right, so I'm going to delete this one. We're going to add this one because this is the actual. What? All right. KiCad, this guy, select that and say okay. All right, and save, come back here, edit this one, make sure the footprint is correct because it currently is not. I want this to be correct. I want this to be correct. Waiting, waiting, waiting. Okay. Stamp, RP20, stamp, stamp, stamp. So I want, oh, I see, because that's what's going on. So the XL Flexi pen looks really cool. I just realized if I do it as through hole, we get instant test points to everything. Yeah, I kind of like that idea. Yeah, I want to do it that way. Okay. Yeah, because then I think I can eliminate a bunch of these test points. All right. And then this one, I think, okay, it's already tied to, all right. Who got you one? You got you one. Okay, whatever. All right, cool. So now what we got to figure out is how do we wire up power to this? So let's add a GND. And then what was I using for my power rails? Oh, so I still need a USB connector for this. Duh. Oh man, why did I delete that? What can we do? What can we do? What can we do? I think the best thing to do is let's just launch another KiCad and go to Oh. Design. Schematic. And then in here, I'm just going to recopy this USB-C. And then for the moment, let's minimize that in case I realize I need something else. Okay. So now the thing is, this requires 5 volts to come in, which we're going to give it. So we can remove this 3.3 volt because this will generate 3.3 volts for us. I'm going to leave an LED for 5 volts. Actually, I'm going to leave the LED for 5 and 3.3 because I want my own LEDs. And then it looks like we're also going to need buttons for boot select and reset. Okay. So then I'm going to bring back my buttons. And we're going to do this and hit X and reverse them. And so boot select will be this one. We can kill this. I'm going to highlight these. I'm going to hit G to drag, move that over. And then same thing for the reset. We'll just kind of do, oh, okay, okay, that's probably a good spot for it. Because then I can do something like this. Let's kill that. And then we'll hit wire and bring this all the way over to here. All right. We can rename these because there's only one of these now. That was a holdover from the old design. I will just copy and paste my lines for USB because I don't feel like recreating those. So that's negative and positive. All right. Interesting. So I'm pretty sure the stamp has pins for the debug, but I wonder if this, what I could do is I could actually put my debug header, which I would prefer. So we're going to do that. So we'll put this back in here, roughly to here. And then let's see, those are upside down. Of course they are. So we'll just do this. No, they're not. Can I make this work? It'd be sweet if I could. Put that there. Put this here. I'm going to rename this reset. Put that up there. Yeah, look at that. That works. Okay. Now, I need to go look up what are we supposed to do with LDO enable. What we do need to do is add this 3.3 volt thingy. And then, do I have a 5 volt thingy? I do have a 5 volt thingy. There. Okay. Going to do a no connect. You know what? Let's just put a test point for the battery. Put that there. And then same thing for bat stat, because I don't know. Well, you know what? We don't need a test point. Never mind. Because we're going to have the through hole pins. That'll be much easier. So much more easier. Okay. So now I do want to go look up what these two pins do. I think I can infer RP2350 stamp XL. That should be plugged in. Mucho bettero. All right. Let's see. Where is It would be nice if there was just a documentation. Yeah, I want to know what these pins can do. Okay. Is there a data sheet for the board? So bat stat, low during charging, high impedance otherwise. Okay. Pull low to turn the LDO off. Okay. And then he has a schematic. Really wish it wasn't called an LDO, but okay. And it's already pulled high, so I don't have to do anything. All right. Fair enough. We're just going to no connect those. And that one. Okay. We're good to go there. I did see something I just realized I want is the UART. So we are going to, so UART is, gosh, why is this not? So IO0 is transmit. All right, and this is going to be receive. And then I would like a serial header because debugging, even with a debugger, sometimes print statements are the goat. Oh man, I sound like an old person. What I want to copy now is I want to copy from one of the Golden Delicious boards. I want to just have a UART header, just so I can plug in an FTDI board and be done. And so it's retro computing. My brain just went blank. So let's pick that off of the keyboard Rev 3. I don't see the keyboard boards. Oh. No, wait. Thought there was two. Yeah, there should be Rev 3, Rev 2, IWM, IO Proto, backplane audio 6502. I'm pretty sure this is not it. Hey, Squire, how are you doing? It is good to see your name up here. Okay, I don't care. This is what I want. All right, so we'll discard that. And then I'm going to close this so I don't get confused. All right, so let's do this. And then we're going to put this over here. FTDI header. This is actually going to be a no connect. And this is going to be a no connect. And this is going to be UART RX and UART TX. Proton Fig. Good to see you as well. How are you doing? What are you working on these days? Actually, Squire, are you keeping busy with work or have you been working on your computer project? I haven't checked in on you for a while. All right, we'll do that. I'm still not convinced that that is right. I should have left this open for just a moment longer. All right, this is the 573. This is the latest version of this board. So I just wanted to make sure that I said IO0, I called it RX. And on this one, I called it TX. Yeah, I'm glad I looked at this. So IO0, he's saying is TX. And I think it is RX. Yeah, okay. RP2350 data sheet. Hey, 48K RAM. How are you doing? In locations, where is the pin table in this data sheet? Here's what I want. So, pin 0 is UART TX. Huh. Okay. So that is correct. Huh. Okay. So somehow I have this is wrong. So then how does my header even work? Or does it not work and I just never realized it because I wired it by hand every single time I used it? Okay. So I know that this is TX and RX, right? TX RX. 2350 TX RX. All right. FTDI, pen out. Hey, Justin, how you doing? So this is supposed to go, let's see, mine right now is upside down. So that's even more confusing. So let's put this over here. And then let's look at this. All right, I will do, oh no, come on, come on. Why can't you figure out how to scale the window? What a terrible operating system. All right. Yeah, so round, what I'm gonna do here is we're just gonna do this. All right, so DTR. So yeah, so this is how it's supposed to be though, because this is RX on the board, so it should be connected to the TX from my microcontroller, and its TX should be connected to the RX. Yeah, so I have it wrong on my other boards. Oh, no problem, George. It kicked Windows to the curb. Gosh, I wish I could do that. I so wish I could do that. Well, someday. Although I have decided, other than for like work stuff, my Surface Book, which is the worst computer I've ever owned in my entire life, it will be my last Windows laptop. I can't get over how bad Windows is on laptops. So, okay. Now I feel like I've got this right. I did want to leave that one table open though, because I wanted to look real quick to see where I squared C0 is. Although it sort of doesn't matter at the moment because I can use I squared C0 or 1. I only need one. Okay, I'm not going to worry about that too much at the moment. We can figure that out later. But I'm going to leave this table open because we're going to come back to this later. Okay, so that's our major I/O. Let's check this real quick. packing up old computers to sell and rehome. No kidding. That's actually what I've been doing most of this week and probably will continue to do this weekend. I decided to finally just get rid of anything I'm not going to be actively using in the near future. I just have way too many things in boxes that I've never opened. And I'm tired of it. So, and it's really hard. In fact, I'll give a really good example. I just sold one of my Commodore SX64s. On the upside, the SID is working, as well as the floppy drive could read and write. Well, it could read. I don't know if I actually tested writes. Oh yeah, I did. I used the performance program, so it could read and it formatted, it read and write to the disk. And all of the keys on the keyboard work correctly, and it has the original keyboard cable, but it was dirty AF, and like even the keyboard is just looks disgusting. And I just said, you know what, I'm just going to sell it as is. I don't have time to clean it. I don't want to clean it. I just want to get rid of it. So I did, and I put it up last night, and it sold this morning. So what's going on here? It's a little bit too much. Ooh, wow. A 2GS going to Iceland. Nice. Wish you sold your Raspberry Pis during this chip shortage. Yeah, I made a joke for a while that I changed the label on my Pi box to say retirement plan. I actually did at one point. So actually, I was thinking about selling. I was thinking about selling them, and then I realized I didn't want to be part of the problem. And I knew that if I just put them on eBay, that scalpers would buy them. And so I'm remembering, I'm trying to remember who now. I believe I gave away 2 of them, but I made anyone that I gave them to, they had to tell me what they planned to use them for, because I wanted to know, I wanted to make sure they were going to get used and not just, thrown out. So, okay, it just occurred to me. I already figured out before I didn't want to cross a boundary. So we need to change our plan here a little bit. There we go. But yeah, it was like the one thing I realized is even if I, try to sell them at a reasonable price, somebody's just going to buy them and resell them at a high price, which is erg. Well, I recommend and only use KiCad. So KiCad. It's today today's versions are well beyond the capabilities of what that other program were. All right, so UART0, that's weird. Oh, there it is. So UART0 TX is on 44 and 45. 44 and 45. Okay. And then what is the next I2C that's available? Somewhere around here, maybe. Let's see. So 46 and 47, we get SDA, or I2C1 and SDA. So let's do this. Let's make a label. Go like this. I'm going to name it that for the moment because I want to be able to remember what it is. So we'll do that, and then we'll do this, and then we'll do this. Oh, I know where it's at. Oh, I know what's wrong. I don't have it in this. Oh, I shouldn't have clicked that. That was bad button. Don't click that button. Bad button. Yeah, actually, I just realized I could turn this back on, I think. Let's see if this works. All right, let's do that. Designing and fritzing. Yeah, I have a super dislike of fritzing, and um, I haven't. I'll start by saying I haven't looked for well over a year, but I don't agree with their philosophy of you have to pay for the binaries. Ever since they went to that model, I completely stopped using it. Um, I mean, they're totally in their right, and if they want to do it that way, they can do. You do you. But that just felt really gross to me. So, and if for those that don't know what I'm talking about with fritzing, it's an open source program which you can, which you can still download, and it's open source, but they don't provide binaries unless you pay for them. And so it's basically you have to, if you don't want to pay money, you have to build it from source yourself. And I don't really care for that. So yeah, a laptop back after 15 years. The only thing I have that's even remotely that close is a MacBook that is so old it doesn't have an H.264 hardware decoder, and so it has a hard time playing some of the HD files that I have. What do I think about FPGA systems? I mean, FPGAs are really cool. I wish I understood them better. Someday I will try, and I will try to get back to learning how to program FPGAs or design FPGAs. I really don't like to say program because it's really not programming, at least not in my opinion. So, one thing I've talked about a little bit with this project is after I get it working on the RP2040 or the 2350, I would actually like to then go back and implement this whole project as an FPGA project, because it actually makes much more sense as an FPGA. But I'm not ready to do that yet. So okay. So then what I was going to do here, oh, I see what I should have done. Let's move these over here. Move these here, move this here. Move this back to, oh, nope. Grab this G to come back to about here. G to come here. G to come here. All right, see how that works. Yeah. The Pi Pico with Wi-Fi is also, it's kind of a special beast. And so like, I mean, if you're using an API, like either the SDK or the Arduino library or Circuit Python, then flashing the LED isn't any more difficult because the APIs all hide it. But things like flashing the LED is kind of silly since you have to turn on the Wi-Fi chip because the onboard LED is connected to the Wi-Fi chip and not the microcontroller, which is kind of, I just think is silly. But I get why it was done that way, but I still think it's silly. All right. I did actually have somebody find me on Reddit and ask me, they had trouble running some of my code on MicroPython, which doesn't surprise me because I'm terrible at MicroPython. Not that I'm not that much better with CircuitPython, but at least I know it a little bit better. But he's like, but the person said it, the code I have doesn't work, which is unfortunate. If Fritzing was free, you'd get what you pay for. Okay, so that gets us, I think, back to basically feature parity with where we were before. And I still have a boatload of GPIO left over, which is really exciting. Now, what's bothering me is the reports that we may not be able to use the PIOs the way I want to use them. I keep forgetting about that. Yeah, actually, now I think about it, I wonder. Okay, whatever. I'm not gonna fret over it at the moment. So now let's do a Q, this, and this. Okay, so now I realize, let's see, I want to move these up here because these are all my LEDs. And maybe we're just going to move all the LEDs underneath the chip. What just happened? What just happened? Well, the file was open. Let's see, the file cannot be automatically restored. So then what's the point? Manual recovery is required. Okay, well, we didn't lose much because I had already done this. All right, whatever. All I had done is I moved the LEDs. Dumb crash. And then I was going to move all of these down here. And then let's move this somewhere else, like up here. We'll leave these over here. Yeah, okay. And then this are these are the capacitors for up there. All right, I'm going to put these down over here. These are the caps for the probe power. Let's do that there. Yeah, I would actually, so the reason I like CircuitPython over MicroPython is just that CircuitPython was forked by Adafruit, and so pretty much any hardware that they sell works in CircuitPython. And then there's a large number of quality of life improvements that CircuitPython has. The thing is, MicroPython has kind of caught up in some of those. They kind of, I don't know if backport is the right word. But the primary reason I started using it is because CircuitPython is 100% disk-based. And so you don't have to use that terrible Thonny program at all. It just, CircuitPython devices show up as a mass storage device, and you can use whatever environment you want, and you save directly to the disk. And every time you save, the program restarts. And that's just, it's really, really convenient. And then, like I said, there's I believe there's other quality of life improvements, but I've spent so little time with MicroPython that it's hard for me to make that compare. The secondary reason I really like to use CircuitPython is simply because if you use a breakout board or a chip that Adafruit is already written code for, then you've got code. You're good to go. So that's why. Okie dokie. Now, I remember where I was at last time, and I almost feel like this is what I want to do at this point. Is so here was the idea: is I have these dual supply buffers, and the idea was I would drive the side that goes to the the 2350 at 3.3 volts, but then have a configurable input side so that the buffers are more compatible with other voltages. And then I thought, what if we use a digital potentiometer to be the feedback network for the voltage supply for those buffers? That way we could have the preset like 3.3 volt and a 5 volt, but then we could also have like 4.5 volts or something. Or maybe if we have a really noisy system, maybe we give them 5.5 volts with the intention of, by changing the supply voltage, you're changing the threshold in which they operate. I'm nervous about putting a digital potentiometer in the feedback loop of a linear regulator, but I want to try it. And so what I think I want to do is go ahead and wire this up here and then move this to a separate board and make a quick test board so that I can actually test if it goes unstable or not. Am I using 805? Yes. In fact, I just installed it right before the stream. I was using 803 previously. Yeah, so like, yeah, actually, I really don't like Thonny. I mean, I feel funny talking bad about it because I used to be such a Arduino IDE apologist, but Thonny is just terrible. Like, and so like I typically use Sublime Text when I'm doing CircuitPython, but there's also some nice Visual Studio stuff or VS Code plugins. But I just kind of feel like getting VS Code fired up for CircuitPython is a little much. Whereas I just like opening up a text editor and going. All right, so let's just look at what they're doing. So the idea here should be, then we're going to add a R small, which is actually going to be the other R, I think. And then let's add a C small. They're showing an electrolytic capacitor. I wonder if these really need the ESR. Uh-oh, that would be interesting. All right, and then we're gonna do this. I'm gonna do this. And then do this. That's not how that works. Okay. Thing is with LDOs, like actual LDOs, not so just keep in mind, way too many people say LDO when they mean linear regulator. All LDOs are, well, actually, that's not true. Not all LDOs are linear, and not all linear regulators are LDOs. So just be careful. But what I was going to say is typically with an LDO, they like to have an electrolytic capacitor because they need a little bit of ESR for their control loop to be stable. If you put a ceramic out there, okay. Let's see, input capacitor, probably the input capacitor won't matter much. And they're saying 10 microfarad for, which is funny because If it's 10 microfarad ceramic, it's not 10 microfarads. Okay. And then on the output, yeah. Okay. So C out's part of the frequency comp. Yeah, look at this. See, this is they really don't want a big ceramic out there. Huh. Interesting. All right. Capacitor snob. Yeah. All right. See you later, 48K. Yeah. The computer, the great computer sell off. Sorry. Not sure what you mean, Proton, about oscillating, but that's where I was getting at. Is if the ESR is too low, the supply becomes unstable and it essentially oscillates, but it just becomes unstable. Okay. This is why I want to. I am going to build this as a separate circuit. Okay, here's what I want to do then. All right, let's move this over here. Because this is our out capacitor. This is going to be the in capacitor. This one I don't care as much about. But then what I want is we're going to bring this down here because this guy is going to get in the way of everything because it's going to come in and connect to how do I want to do this? Do I want to connect from here to the wiper, right? And then this way, wherever we move the wiper, that becomes R1. And then this is R2. Right? Am I thinking about that the right way? And then what I'm going to do is we're going to add a footprint here. We're going to do not populate this. I got to think about what value I want that to be. So if you're using multi-layer ceramic capacitors, which is what I'm going to use, then no, you don't need a 100 nanofarad in parallel with a larger value because multi-layer ceramic capacitors are already small capacitors in parallel with each other. The other reason it's less necessary on a linear regulator is because there's not that much its control loop can actually handle some high frequency rejection already. And so between the linear's control loop and the multi-layer nature of a ceramic capacitor, there's not really much of a value of putting like the where people do this silly thing where they say, oh, I want this, and this. The thing is, this 10 microfarad capacitor already has about 100 nanofarad capacitors inside of it. So all this does is add inductance. So it's one of the it's a thing where it usually won't hurt, but it doesn't actually help. Yeah, I mean, data sheets usually tell you how to place the caps, but you also just have to know from circuit design. I mean, what's going on in this case is this is a decoupling capacitor for the input so that this capacitor will decouple from the, well, I need to actually put it in here. We'll decouple the regulator from the 5-volt supply. And then this is a filter capacitor on the output of the linear regulator. And so its purpose is to actually filter out low frequency noise, ripple out of the regulator. So, and then this capacitor down here, this is essentially it's for to change the loop compensation. So the problem is that by using this potentiometer isn't as linear. It's not it's not as linear. That's actually not the problem. It's more reactive than just a traditional capacitor. And so I'm pretty sure I'm going to have to use a compensation cap to change the effective reactance of this element. But I don't feel like doing the math and figuring out what that's going to be like. So we're just going to build it and then see. So yeah. So part of it is the data sheets will often tell you what to do, but I mean the other part of it is it's circuit design. You just have to know. You have to know where the where parts go. All right. I wanted to grab one of these because we'll need a decoupling. Speaking of decoupling cap, we'll need a decoupling cap for this active IC. And then we're going to have to connect all of this to the SDA lines. So let's come back and copy these real quick. I don't know what's going on. I got all my programs mixed up just now. I was trying to do hotkeys for three different programs at the same time, and that was a bad combination. Hey, GB, good to see you. You don't remember any of this stuff? Me either. I don't know what I'm doing. I'm still not convinced I wired this right. We gotta go look at the data sheet. There's something about doing the potentiometer this way. I think if this was a real potentiometer, this is fine because the idea is the wiper will go all the way up to where it'd be basically 0 and then it goes all the way down and it will be the full resistance of the element. But I have a feeling that because a digital potentiometer isn't a resistor, that might not be how we have to do this. So I have to go look, but I'm not going to, well, I guess we could go look right now because I need to find out what to do with this shutdown pin. And I think 01 and 02 are extra, I think those are extra outputs that I don't care about. I think you can send I2C commands to make those do stuff, but we don't really need that. We've got plenty of IO left over from the 2350 data sheet. I would argue, you know what's funny about reading data sheets is, and I've tried a couple of times to write some like document or like do a video on how to read a data sheet. And the thing is, there's a couple of things you can pick out of a data sheet that I think everyone should know. Like, for example, when you look at specifications, and of course this one doesn't, yeah. So the biggest mistake I see people make is they look at the absolute max and they're like, oh, this chip runs at 7 volts. It's like, no, this is where you destroy the chip. So this is absolute max is almost never the chart you want. You want to go find in the regular spec table what is its operating range. Now, it turns out operating voltage range is a bad example because it's usually only spec'd in the absolute max, but never mind. Let's find the shutdown pin. SH, I think it's shutdown. So what is this? This is active low connection of the wiper and open circuit should be tied to VDD if not used. Okay, I don't know what those words mean. I recognize all of those words, but not in that order. So shutdown can be activated by strobing the shutdown pin or programming the SD bit. If RDAC okay, it's placed in shutdown by software, the SD bit return. In addition, shutdown can be implemented with the device digital output. What? Okay. is shut down during power up, but users can program the device. Thus, when it's programmed, exit shutdown. This new, yeah, okay. I actually like this idea. Okay, that's what we're gonna do. So basically, this I like what they're doing here. So this will so basically we can pull it down to the ground, and then we can use one of those outputs I just said I don't need, and then we can actually take that output to go high, and when it goes high, it'll turn the device back. It'll turn the device's wiper on. Which I don't want because I don't have a way to turn the the regulator off anyway. So okay, so we're going to tie that to VDD since that's what it said to do. So let's go back here and let's do a grab 3.3 volts, move this over here, and say that's going to connect to that. And then for these, you know what we're going to do? I am going to put these out to test points just in case. I wish I had. Okay, I know I want. Oh, well, yeah, we'll do this. I want this to be a test point. I want this to be a test point. Just in case I change my mind later. And then we'll go ahead and throw one on here. There we go. And then that way we're covered. All right. Okay, the other thing we haven't figured out yet is what resistor do we need? So how are we going to do this? Okay, let's fire up a spreadsheet real quick. So we need to know VREF. Hello, hi, how you doing? R1, R2, I adjust, and then we're going to use all of those to calculate V out. And V out is going to be equal to this one times 1 plus this divided by, you know what? Oh, this would be a perfect time to use octave. Oh, well. All right. Okay. So VREF, we got to go find R2. We got to figure out. So our goal is I want to figure out what R2 is by changing V out. And then let's see now, where is VREF? VREF is probably like 1.25 volts. Yeah, 1.25. It's always 1.25. I adjust is if V in minus V out is 1.4 and we're at 10 to 80 milliamps. Okay, so I adjust is going to be I'm going to go a little high. It's going to be 0.5 e to the negative 6. And then we're going to actually, I want to do this for all three of these. Oh, I don't know how to do. I don't know how to do engineering notation in this program, so I'm not going to bother to try. Yeah, actually, score. Yeah, that's why I decided to take just to tie it high, because if I had the ability to disable this, I guess I could use a different regulator if I could disable the regulator, then I would want to be able to control the wiper, or it'd be nice to have control, but it doesn't matter. Okay, so then what we're going to, so then the whole idea here is if I said 100K and then 50K, our output would be 3.8 volts. And just to demonstrate what's going on is, wait, did I do that wrong? 100K and 10K, that's probably what I meant. So maybe 100K and 50K, 1.9, okay. Because I think we want R1 to be bigger than R2, is that what it said? I almost never do this math. I'm only doing this as kind of a little bit of an exercise, but no, it's saying the reactance of C adjust, that must be less than the resistance of R1. All right. But the reason I'm going through the effort is because we don't have full control over R1. Have a good dinner. Food is always a good idea. Oh, there was 1.25, the program constant core. 1, 2, let's see, is usually selected be greater than the specified. Yeah, okay. So they actually want to make, they're actually saying make that whole current 5 milliamps. So they're saying take this voltage and divide it by this plus this, and the goal is to make this 5 milliamps. Gosh, I would really like this to be in engineering notation because my brain does not work. I don't want scientific. The thing is, I use Google Sheets a lot more. Is this what I want? That's what I wanted. And, but Google Sheets doesn't have a data finder, which I think is stupid. Like, a solution finder. Okay, my brain is much more happy with that. Third and 5, e to the third. How the hell do you get 5 milliamps? With the, God, those are really, really low. Oh man, no, I forgot where it's at. They call it goal seek. It's the formula is in this cell. The target cell is, our target value is by changing this cell. Whatever. Whatever. Oh, doesn't matter. Actually, this does matter because I'm worried that these buffers aren't going to draw enough current. Especially because these are the input buffers. So I would like this to be 5 milliamps. So why am I, what am I, so it's 100 ohms. These values seem way too, okay, this isn't going to work the way I want. This is dumb. Yeah. The problem is this potentiometer is going to be 100. Okay. So where I was going to go with this is I was going to use the feedback resistors to force them to, or to force the regulator to have a 5 milliamp load, because these are driving the buffers, but they're the input buffers. So I'm just worried that we're not going to have a lot of current draw, which means we won't get a really, oh, you know what? I'll just add a resistor. Never mind. Okay, this is dumb. I already know how to. Where I'm going with this is I want to make sure that this regulator, because it is the voltage reference for, essentially we're using it as a voltage reference. I want to make sure that it's stable. And if a linear regulator doesn't have a minimum amount of current going through it, then it's not able to regulate its own voltage. So all we got to do is we just got to put a 1K resistor out there to make sure that it's always drawing 1 milliamp or 5 milliamps. Anyway. Okay. Whoa. Yeah. I was, especially in a design like this, I have plenty of, it's not like we're space constrained. In fact, let's just add that right now, just so that I don't forget. Let's just, what I'm going to do in this case is I'm just going to put the footprint. Well, actually, we will go ahead and say 1K. All right. There. Now we're good. Now I'm not going to worry. Okay. So the next thing is, and this, you guys are going to laugh when I say this. I don't even know what the value of this digital potentiometer is. So we got to figure that out next. So I said I want part number 85247. I believe the 1M means it's a 1 mega ohm. So that's not going to work. That's not going to work at all. I know why I did that. I know, okay, yeah. I did it because I think that's what I have already available. But I think putting a 1 mega ohm impedance is going to be a terrible idea, because we're not going to get anywhere near the current we need for the feedback, because we have 1 e to the 6 out here. And then let's do target. Let's see, formula cell is this one. Target value is 5, and the variable we can change is this one. Yeah, that's not going to work. Because it's not actually a reference, it's a supply to, it's the supply for, it's the voltage supply for the buffers. And so I guess I could go and understand what the actual current draw is going to be, but I don't feel like doing that. So that's why. The idea is, again, the idea is I've got these dual supply buffers. And so by changing the voltage supply on one of them, I effectively can change the voltage threshold for that set of signals. And so the most obvious case would be is if I'm probing 3.3 volt signals, then I want a threshold around 2 volts. But if I'm probing 5 volt signals, then I want around, what, 3 volts or something, whatever. But being a logic analyzer, I want to be able to pull this up and down just to make it more useful. Because, like, for example, on the digital discovery, even though it's 5 volt tolerant, its threshold voltage is around 1.8 volts. And so it, on a noisy bus like in the Mega 2, it will pick up stuff that is below 2 volts as a transition, because I can't adjust its threshold voltage in any way. So I don't know. I'm just trying to give some added flexibility, and I'm doing it that way. So, Okie dokie. I know why I had wanted to do this. I didn't want to buy new parts, but I think it's really dumb to put a 1 mega ohm anything in a, well, actually, now I think about it. No, I want to do the 10K. Yeah. So if we make this 10K, and then tools, goal seek, target value is 5, formula cell is this one, variable cell is this one. Let's go. So then we got to find something around 29K. That should work. What if we did 33 to the third? All right, and then that gives us, I mean, we're not going to get to 5.4. So what if we did 2070 to the third? And then if this goes to 1e to the third, nice try. So I actually need it to be R2, I think. Because really? Really? That's sad. Oh, I know why, because I didn't do it right. Yeah, there we go. That's the same. That's the same. But what if I swap these? Right? So then if we over here, we do data tools, goal seek. Let's change that to 5 by changing this one. Huh. So 1 to the third, 2 to the third. Why didn't it figure this out? Yeah, I don't. Target formula cell, target value 5, variable cell is this one. There it is, 3.3. And we drop this to 1e to the third. Okay, yeah, that's how we need to do it. So R1 needs to be our fixed resistor and R2 could be our variable resistor. That'll work. Okay, we're gonna go with those values. Ah, no, 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 no. Nope, that's not what I want either. I'll go find the police. Stupid. Find the police. Don't want to find the police. Test. Nope, that's not it. All right, we're gonna name this. We're gonna just name this. So what we're gonna do? We're gonna do one of these. First, we're going to redo this. because this is going to be up here now. This is going to be 3.3K. And then this is going to come into the wiper. And then that's going to come around to adjust. Wait. Why was that going to ground before? What was I doing? Okay. I know what I think what I want is this. There. And then just to stop my brain from being really confused. So the idea is it comes in through here. Why am I having a hard time picturing this? Yeah, this isn't, I don't like this. I don't like this at all. Because this goes to here, because this is the same thing as if I drew this. Right? So then if we, well, then that's right. That is right. Okay. Okay. I think my brain just doesn't see it. Hey, in Boulder, nice to see you. Yeah, my brain just wasn't seeing it because it goes through this resistor and then this effective resistor to ground. But then between this resistor and this resistor is that voltage point. So yeah, it just doesn't look right. I do think I'm going to add a test point here so we can know what's going on. Yep, it is. That's why we're going to test it first. Okie dokie. So all right, so here's what we're going to do. First, I need the 5 volts. So let's grab that real quick. Because that's obviously something we'll need. So that should be here. And then I want to fix this part number. That's going to be our next thing. Where is part numbers? Ordering guide. Yeah, so it's just I want the 80, 52, 41, BR what's the BRZ versus the BRUZ? Ah, packages are different. So if I have a BRZ1M, yeah. I definitely want the BRZ10. And that's still 14. Yeah, okay. Yeah, good to know. Voltage range is going to be 2 to 5 volts ish. This is powering a, yeah, I just heard that too. This is powering the supply for a dual supply buffer. The idea is to have a higher be able to have a variable voltage on one side of the buffer so that we can adjust the effective threshold voltage of the buffer. So, how are we going to get 5 volts to those then? Huh. Whoops. Hadn't considered that, did I? Yeah. Yeah. Huh. 1.5 volts. Shoot. Hmm. Okay. What we're going to do is this. I got it. In fact, now we don't have to build a separate board because I'm going to build in the fix. So we're going to come over here. I'm going to do this. We're going to add con sonar. There. So we will just have a header for the threshold to select. We'll just do it that way. Solved it. Do the voltage divider for the digital pot into emitter follower. You mean the output of the regulator, or you mean the output of the pot? Yeah. Yeah. The original reason I was going this path is just because I had the part. I guess I don't have the adjustable NCP, but I had this digital pot. I have extras of these. However, I'm not happy with using the 1 meg. So If I have to buy this part and this part, should I do this a different way? Yeah, that be the question. What is the current draw of these guys? So what was this? So what do I want? Like a quiescent current, maybe? If VI is VCC or ground and I is 0, 1. So, yeah, so current of ICCB, if VN is equal to VCCI or ground, then why would this be 0? So it's looking like, oh, maybe this is closer to what I'm looking for. So 15 microamps each, is that what I'm seeing here? Yeah, I don't know. I'm feeling like, let's see, one port. Oh, what did I just do? Oh, there we go. Yeah, I mean, I'm building one of these, so I'm not super worried about cost. Uh, yeah, okay. So my takeaway on this one's going to be, I'm just going to say 50 microamps each. I'm just going by the biggest current number that I'm seeing. Keeping in mind, I'm only talking about the one side, which is always going to be an input. I know the output side is going to be a little bit higher, but it's looking like their worst case are going to be 50 microamps each. So that's what, 50, 100, 150, 200. And then this is a couple of ports. Let's just call it. So 1, 2, 3, 4, 5. So seriously, we're only at 250 microamps. We're not even at a milliamp. I mean, we could find something to drive it much better than that. Okay, I want to think about what I want to do then. originally I was thinking go ahead and just build this board, but as I think about it, like I said, I don't. If I had both parts, I would go ahead and just do it. But I don't have this. This isn't the pot that I have, and I don't even have this regulator. So yeah, yeah, that's where I'm sort of thinking is if that's actually what I'm thinking is if I just need a couple of milliamps. I see what you're saying. What you did, you just did an I squared C ADC, go into an op amp to buffer it, and then just let the op amp drive it. That might, yeah. Okay, you know what? I still want to build this, but I don't think I'm going to use it. So I'm gonna let's go ahead and do it this way. Here's what I want to do. Let's just do this real quick because now I really want to see how this is going to work. But I'm already convinced I don't want to use it. So just to put that out there, I don't want to use this. I'm actually liking the ADC and op amp idea, especially when now I realize we probably don't. I mean, if we really only need a couple of milliamps of current, then I mean, even if these, let me think of it this way too. There's 1, 2, 3, 4, 5. Even if these all needed a milliamp, we should be able to find an op amp that can drive 5 to 10 milliamps, no problem. Um, uh, I don't have. I know for a fact I don't have any adjustable 117s. I almost never use an adjustable regulator, so I already know I don't have one. Actually, tell you what, let's just double check because now that I don't care, maybe there is a different regulator we could use. Parts. I guess I can delete that file. Use that one. All right. Can I highlight? No. ADS. Oh, okay. I always like to have somebody else's starting point. Actives, surface mount, type, LD, linear and LDO. So let's do a filter. Oh, where's my filter button? Filter, clear, LDO. Oh, there we go. Linear. Okay. So yeah, so I've got a 3.3 and a 3.3 and a 5. I'm pretty sure the 2870 is a fixed regulator, but I have two of them. Because this is the Japan micro devices. Yeah, I'm pretty sure this is a fixed. So yeah, I don't remember what value it is, but it's probably 3 or 5. Okay, so I don't have a linear regulator. What about on through hole? What do I have? An LM317. You know what? It doesn't matter. Okay. Yeah, okay. I mean, why can't we just do a DAC? The the 2350 doesn't have a DAC, right? Yeah, it doesn't. In stock, active. Actually, I don't care if it's active or not. I want one channel. I want I squared C. Ugh, make it so hard. What was I gonna look for? Let's do this. Just do this to try and get these into packages that I'm willing to deal with. And then what do I want in terms of, well, I'm curious. More and more curious. $10. Yeah, that's a bit much. That figures. $1.27. What's its range? What was it? 12-bit? Yeah, we could probably live with 12-bit. Can it do rail? It can go rail to rail. Hey, Francois, good to see you. Low power, high accuracy, of course it is. Non-volatile, blah, 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 bit tied to blah, blah, blah. Oh good, it can run at 3.4 megahertz. I was afraid it wouldn't be able to handle high speed. All right, so what I'm curious is, what is its output current? How much, because it says, I'm assuming buffered means its output is buffered. So then, how much could this drive on its own? Let's see, current at output pins, 25 milliamps. I feel like for $1.25, yeah, I'm gonna go back and reread what it said about the EEPROM, but I'm feeling like for $1.25, sorry, $1.27, this just seems like exactly what I want, right? Because its maximum output is 25 milliamps, which I believe is well beyond what I need. I mean, even if those were 5 milliamps each, then okay, we'll be pushing it, but that would be okay. Let's see, DC output impedance is an ohm. Okay. What was the output range? It said rail to rail, didn't it? Did it not? VDD up to 6.5. Okay. This is what I want. Output amplifier. No, short circuit current. Okay, so really, okay, check this out. So if I'm not sure if short circuit current means this is bad for it, or if it starts acting like it's being shorted between 15 and 20 milliamps, but that's still more than what I need. If I'm right. Okay. This is okay. I think I'm just gonna go with this one for now because it's $1.25 or 27. I mean, Yeah, so the only other thing I want to make sure is I get the right part number. Packaging. So part number is something, 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 something. So MCP 4725 A2T-E. Oh, that's the address option? Okay. That's interesting. There's no address. Is there no address pin? There's one address pin. Okay. We'll just, yeah, that's fine. I'm just gonna put it there for now. Is an ideal DAC where device simplicity, small footprint, requiring the DAC settings to be saved, I2C, external address, power on reset. Okay, the DAC and the program, non-volatile, enables the DAC to hold the DAC input code during power off, and the DAC available is immediately available after power up. 14 other devices. Okay, I like it. This is what we're going to use. So let's do this. Let's save. I guess Control S doesn't do anything there. And then let's go to here. I don't know what I want to do about that. I'm going to delete that, actually. Interesting. So let's stage that, and then I'm going to do remove complicated VCCE supply circuit. I don't know if you can read. I assume you can read the DAC value. I don't know if you can read it. Okay. But I'm glad you said that because we will do. Okay. Let's go ahead and do this. Okay. Take out all of the. I'll leave that. I want that. Okay. So then I want to. So what I was going to say is, let's tie this back to one of the analog inputs on the microcontroller, so that we can at least do a check to know what it's set to. So we'll just close the loop. Even if it lets us read what it is, let's verify it is what we think it is. I mean, I know there's going to be. I don't even want to say calibration, but wait a minute. Is this a write once only DAC? Would a write once only DAC ever be useful? Oh wow, man, KiCad's default libraries are sometimes shockingly good. Yeah, this is basically what we're gonna get, right? MCP 4725 A2T E/C. Okay. All right. All right. Let's do this. Let's do that. I mean, that digital DAT or that digital pot was something that it's like, I think it's like $10, which is why I wanted to reuse the one I already had. But realizing this will probably do exactly what I want is cool. We're just going to tie that one to ground. And then we need our locks. Oh, I just realized I was making a silly mistake. All right. Okay. So then we're going to take this. I'm going to come out here. Oh, I already deleted it. I am going to put this connector back in. In case I want to force a voltage onto this bus or onto this rail. So I'm going to do something like this, but then I will go ahead and put the 5-volt here just in case we have to override it. But the idea is this way I can just use a header pin and then we can mess with it from there. And then I'm going to add a cap out here. And this is just going to be a footprint. I'm really tempted to put an inductor here. So that we can build it as a low pass. I'll compromise. We'll just put a resistor. Well, we'll start out with a 0 ohm resistor and then maybe we'll change it to like a 22 or something. I just feel like I want something. I want a pad there so that I can do something with it. All right. Yeah, I agree. This is a much simpler path. I don't know if it's going to work, but at least it's simpler. Oh, good. And it's a microchip part. So if I advertise that it's using a microchip part, microchip will talk about the project. Okay. Yeah, that is like a lot easier. That's going to be a much better way to go. Oh, that's an interesting idea. Huh. Yeah, I like that idea actually. That's clever. Okay, let's add some footprints. So we'll go use my favorite table. So the caps, oh, these aren't the order I care about. 0603? What? What? Why are we using 0603s? That's not. All right, we'll just use 0603. What is this one? This is a jumper. Pin. No. What do they call them? Well, it doesn't matter. This is what I want. Okay. All right. I'm with you, Squire. Just in case, we'll do one of these. We'll just do that just in case. Why not? I'd rather have it than not have it, especially since I'm not entirely convinced this is going to work. Okay. I tell you what, at this point, what is this? Oh, I want it to have diodes. I don't want to figure that out right now. Here's what I want to do. I want to save this and I want to run DRC, ERC and see what it tells us. And what might not work? I forgot already. Yeah, I don't remember what I was thinking. Okay, let's see what this says. Get the optional filter cap as it mounts instead of R to ground. Yeah, basically, I'm just gonna do 2 pads, and that I get where you're going, but I think in this case I'd rather have it just in case. Oh yeah, we didn't set the direction of any of these. Whoops. Okay. I mean, there's just gonna be 2 pads next to each other, so it's not like it's gonna be a big deal. What is the dir pin? Where's the table? All right. No, that's not the table. That's not the table. That's not the table. That's not the table. Don't they have the truth table? Because I don't want to think. Please don't make me think. I can't brain. Brain is done. Hey, Francois, thanks for stopping by. Good to see you. Run DRC. Yeah. Should you run ERC? Yes. Yes, you should. Where's the they have, I thought they had a truth table so that this was a lot easier to tell which way it was what. Or is that what this is? So direction, no. Come on. Just tell me, should it be high or low? That's what I'm looking for. Table 7.1. So if it is low, data goes from B to A. So B to A. That's what we want. We want that to be low. All right. And then because I don't trust anything, we're going to put in this part number and ask for a data sheet and verify that this is also supposed to be low. Data B to A. A high on, okay, I want the table. Just show me a table. There we go. So if output enables low and direction is low, then we go B to A. So that's still the same thing. All right. Like I said, I just wanted to see it. So that I would have confidence. All right. Let's try DRC again. 19 errors, down to 1 errors. What's the 1 errors? This is not, which supply? What? Oh, okay. Fair enough. You're mad because this pin over here needs a flag. Power flag. Unvisible that. you got SPY going? Nice. Like in TTL hardware, you mean? Or does SPY mean something different in this context? Okay, so no errors. That's good. Both of these are attached to the same item, V3V and VCCA. Okay, you know what I want? I want to do the same thing I did on this other one. I'm just going to put I want to do this but with a header. Um, I'm going to change this to be, okay, that's better. All right, so let's do that. And then we probably will have to add a flag. Yeah. Let's do that. Oh my gosh, I have no idea what I just pressed all the things at once. Okay, let's do that. There. Much better. Oh, nice. That would be a circuit I would like to see. Yeah. I think I will watch that, but I think what I had noticed, I think I can get all of these direct from TI if I need to. Because again, I'm not building a lot right now. But I might also be thinking of the 245 single supply, which is usually pretty easy to find. What is off grid? All this crap is off grid. Are you kidding me? Are you kidding me? Are we going to get lucky? Can I just highlight everything and then do align to grid? Almost. So these are still bad. So let's just do these two. All right. I just realized I don't need that resistor because I believe that's already in the design. Where did I put? That's not what I wanted to do. uh, okay. This is what I want it. We back this up. I'm looking for his schematic because I want to know on his reset, he pulls it high externally. Wait, no, that's the actual RP2040. So, okay. For the, where's the chip? Where's the chip select? Oh, does his board already have the switches? It has a reset switch. And then what about for chip select? That does not appear to be having a switch. There it is. He's already got the resistor in there. Okay, beautiful. Just wanted to verify that. All right. Let's try this again. Oh, did I say DRC? I keep saying DRC, didn't I? So this has been modified. I don't care. Ignore. This power flag has been modified. Okay. Ignore. This is not, this symbol is not found. Also, I don't care. Ignore. And that's been modified. Okay, cool. Run ERC one more time. Well, that's cool. So ERC says there's no errors, which we know means there's no errors at all anywhere in the circuit. Yeah, actually having an additional reset button away from where the original reset button is sometimes a really nice thing. That's why, like, whenever I make something like a feather or whatever for a wing or shield or whatever you want to call it for whatever kind of board, I always try to add the reset button because you're covering it up. It's like I wish you could also. I wish that like the boot pins would also get broken out so you could duplicate those as well. Okay, let's. I actually want to close this now because I'm going to do update PCB, and I just want to make sure that the project file is taken care of. And then over here, I'm going to close this. Don't save. Show and Explorer, because we're going to just delete this. We don't need it. Since we're not doing the LDO anymore. All right, so this is going to be, let's see, moving from schematic to PCB. All right, George, have a good one. Thanks for stopping by. The only reset button you need is a load switch to turn off the power. Yeah, there's always that as an option. And I did find a really nice, the load switch I use on the Balt Sense, I really like it. I don't know why. It's nothing special, but it's relatively cheap and it seems to work just fine. I'm really excited about this DAC idea. I'm curious to see how well this works out. Kit, yeah, that's because I upgraded. All right, so cannot remove unused footprint, cannot add, no footprint assigned. That's not found. Okay, hold on. All right, so I'm going to put this over here. You guys can't see it, but I'm not going to update the PCB yet because I want to fix these problems first. So first thing we need to do is figure out where my footprint for the fish is at. I wonder if I have to include, like, oh, you know what it is. I know what it is. I don't have my footprint library. Wait, that doesn't make sense. All right. Okay. This is the LDVK. Yeah. Select. Okay. All right. So that one should be fixed now. J10 has no footprint. I'm not surprised by that. Why doesn't ERC pick up on missing footprints? I feel like that should be a warning. All right, cannot remove, cannot remove. Okay, let's try this again. Okay, cannot remove, cannot remove, cannot remove. I'm okay with all of those because I'm actually going to remove them right now. All right, I'm gonna put this like right here for the moment. I am gonna come in here and let's unlock these. All this. I don't know. Yeah, okay. We're just gonna delete those. I don't know what the other one is. Oh, it's this. Okay. Okie dokie. So now we can move this to be roughly here. Then we got to figure out where that's going to go. And then somewhere we're going to have this USB thing. Where is the data lines for the USB? Oh, they're behind. Oh, I wonder, do I need resistors? Probably, because you want the resistors next to the port, don't you? So even if he includes them, well, if he includes them, I don't want them. USB plus minus. Yeah, he's already got resistors on the board. Which, don't you want those next to the port and not, whatever. It's USB 1.1, who cares? Let's do this. Let's get this next to here, and then, yeah, of course that's gonna happen. Can bring this over to here. Then I can go throw this. Yeah, I don't care. Well, okay, but if ERC is going to check if parts have a SPICE model, then I think they should check if they have an assigned footprint. Like I said, I think it should be a warning by default. That's my only point, is just that I think there should be a warning available to say, hey, 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 hey. This really bothers me because if he's already got the 27 ohm resistors, and his board doesn't have a USB port, huh? That's awkward. Very, very awkward. All right, fine. Fine. Yep, DN. All right. Oh, that's not what I wanted. We're gonna move this over here. All right, that makes that a little bit easier. Okay, so USB signals are somewhere over here, I guess. No. Okay, I'm not sure how I want to do this yet, but we'll see. Move this, because like, what this is, so what this, oh, you know what? I'm going to move these out of the way for the moment. I think we're going to get rid of the test points because that's why I went with the through hole version of this, because we get the test points for free now. All right, let's do something like this. What I'm thinking towards is if I'm going to make the space for that, and then we can do something like this. Where are these guys at? All right, come over here. I'm going to hit P for pack and go. And then what if we said all of these are going to now come up here? Nope, I don't know what I just did. Do something like this, and then do something like this, right? What else is over here? Is this the FTDI header? which basically just needs the UART pins. So then this can go like up here somewhere. All right, and then I think I have like my power LEDs. Where's this LED? And this one, and this one, and this one, and this one. Okay. So these, okay, I don't know what I'm going to do with these yet. But these could end up like up here somewhere maybe. And then these LEDs are going to end up somewhere up here maybe. Let's undo this. All I want right now are footprints. What is this chip? Oh, okay. So that's going to end up over here somewhere. And what is this? Oh, okay. You know what? We don't need that either because we have the through holes, so we don't need that. All right. Okay, and then this will go near the op amp or the DAC. This goes, well, I might punt on my ESD protection. All right, so this whole circuit, let's just highlight all of these, come over here and say pack and go. All right, let's move all of this stuff over here. And then that's got to go somewhere up here. All right, and then what's this one? Yeah, so this one's going to go right next to it. And what are these? Are these all, let's see, what is C6? Oh, C6 was supposed to go with that. Whoops. And then we got this and this. These go with the USB port, which are probably going to go on the back side, but for the moment, let's put them right there. Cable's wide. Okay, good point. I don't think this probably doesn't have the 3D model. Yeah, okay, I'll move it. I'll still move it. I think it actually ends right, but yeah, that's fine. I'm good with that. Let's go ahead and just move this down. I mean, did I make this footprint? Because I feel like the courtyard should actually be the total width of the cable. Maybe I'll go back and fix that later. Because that's a good point, because the courtyard should take care of that, at least in my opinion. That seems like, yeah, that's definitely one of the, that's something I have zero interest in doing right now. But as soon as I stop streaming, I'm going to forget that Alex said that. And then I'm going to be mad when I get the board back. But what I really want to do is I'm going to go measure my cable, and then I'm going to make sure that this courtyard is at least that big, probably, slightly bigger, just so that I don't have that problem in the future. All right. So the other thing is we're just going to take out these, we're going to take out all these test points, because what I'm going to do is I'm going to use my test headers when I attach the stamp board to my board. So we'll get these. This is going to be awesome. So those are gone. We're going to take those out. Take those out. Take these out. And take these out. I'm not going to get rid of all the test points, but those were all, they're now redundant. So yeah, I'm with you. I think in my mind, I haven't had that issue in the past, but that's an invalid reason to keep doing it wrong. I like the idea of I want to make sure it's wide enough. So, well, actually, Geek, that's what I'm doing. We're using the through hole footprint of this stamp board so that I don't have to have test points. See? So, I think you're so clever. Okay. Oh man, what's all this crap? What's a C7 for? And what's this one? And what's this one? Okay, that's easy. These all belong. I'm just going to put them right here. Those belong with those chips. And then what's an R, whatever this is? Why does that have a? Oh, I know what I'm doing. Okay. Those actually are going to go up here somewhere. All right. So then what's over here now? Why is there a fourth hole? What? Whatever. All right. Well, that's not what I want it to do, but you know what? For the sake of in the moment, let's just do that. It's snapping to the center of that. It's not what I want, but who cares? What else we got over here? Let's see. Test points for I squared C, which we're just going to put those on the back of the board because why not? And then where are these resistors at? Oh, right there and there. Okay. And then we're going to put these somewhere over here. All right. And then what is this? This the blinky LED? Is this its LED? Its resistor? Okay. Let's see. That's going to go up here somewhere. We'll clean all that up later. And then we've got some ground test points, I think. So I'm going to grab these. I'm going to do a P to bring them all together, and then I'm just going to put them all right here because I don't know what I want to do with these yet. I just want to have them available. So we'll mess with those later. Let's move all of this over here. Oh, nope. Select all items. Let's move all of this over to here. What's this cap? Whoa, and then that cap. Okay, both of these, I believe, are supposed to be with the buffers. So I'm just going to do this. We'll worry about where they actually go later. Okay. What else is over here? I don't think there's any other components. Okay, I'm going to undo footprint because if there's any components left, I want to not select them. And then I'm going to delete. That was our old design, Rev 1. It's gone. No more. Never again will you see it. It's gone. I don't know what to tell you. Ouch. That, ouch. That's funny. You said that. Yeah, that's bad on the, that's a bad mistake to make. Okay, so I am going to say it now. I like where this is going. No, I gotta figure out why I want to do that, but other than that, on that little minor itty bitty thing. I think I'm gonna like this. Yeah, yeah, yeah. I'm really happy to use this module instead of um, doing it discreetly, because Artuo, man, I wish I knew how to say his name. Solder Party has already done all of the hard work. And I'm not really in the mood to butts with another QFN anytime soon. What am I looking for? What was the name of this? It's this one. KiCad. And then 3D shapes and the Stamp XL. I believe it's single-sided. I mean, I really hope it is. All right, so that's 0 and that's 10. And the silk screen says 0 and 10. So that looks good. All right, let's save that. Close this. Do update footprint. Update. Close. Alt 3. There we go. Come on. There we go. Look at that. Yeah, that's going to look real nice. That is going to look real nice. Yeah. And then there's even a footprint to add a PS RAM. That's going to be real nice. Okay. I think we can get this easily reduced by 25% in terms of X and Y, and maybe even a lot more than that. But as a starting point, I'm very happy with where this is at. And I'm giving thought to getting this one assembled just so that I don't have to deal with it. Which actually, if I do get it assembled, then I might change the headers to be surface mount. Because I don't want to deal with them. Not these though. I probably won't do these as surface mount. I want these to be through holes so that they're extra strong. So anyway, all right. I think we'll stop there for now. I am still tempted to build a demo board with. It might actually be worth building a demo board with this DAC and one of the buffers, just to verify how much current it actually will draw and how stable its output will be when powering a buffer. I need to give that a little bit thought. It might make sense to do that as an intermediate step. That way, because then I could add, that way we can add a couple more test points like measure current and then maybe we hook it up to like the digital discovery, which would actually be kind of neat because, or actually we could hook it up to the analog discovery because I think the analog discovery has variable output. Um, Maybe not. I was thinking if you, not voltmeter, that's not what I wanted. I was thinking if you did the supply. No, I guess not. Okay. We're using, so the DAC is in replacement of a LDO with a digital potentiometer because I want to change the voltage. I want to program them. I want to be able to. I want a variable voltage on the input supply to the buffers, so that we can move the effective threshold of these parts around. Which just reminded me, I totally. Oh, maybe this is what Squire was getting at earlier. I just realized this. What we can actually do is if we do something like this, 10K and 10K, because what is 5 divided by 20, 1, 2, 3, 1, 2, 3, still less than a milliamp. Okay. And then we do feedback. Now, which GPIOs on the RP2350 are analog? Huh. I don't know what any of that is. Analog is able on those for a total of 4 and on 40 through 47. Okay, so what sort of what I guessed, but 40 through 47. Okay, so for lack of anything better, I'm going to do this. All right, and then we're going to put that here. See how that goes. This is KiCad. Yeah, I think it's going to be fine. That's why I still like the idea of doing a test, though, a test board. And in fact, what I could probably even do, yeah, I would still like to do a test board. I am a little bit curious on how stable it's going to be. But yeah, you're right. It's all the inputs, so it doesn't matter. It shouldn't matter. Yeah. Oh yeah, the other software is waveforms. My bad. Yeah, I forgot. That's for the analog discovery. I really thought the analog. I thought the analog discovery could change the output voltage of the pattern generator, but now I realize I don't know how it would do that. I don't know why I thought that. Which is okay. Um, what we could do is we could just use an actual function generator, and then we'll just tie, like, I mean, even the digital discovery has, or analog discovery has, two wave analog outputs. So we could tie like 4 of the channels on one and 4 on the other, and then have, yeah, we can actually mess around with that. Include a buffer to evaluate the threshold. Well, hmm, okay. Yeah, let's make a note. Actually, actually, a test board would be is still making sense to me. You know, what if we just like grab this part right, you know, this stuff right there, and build a little test board, and then that way we can evaluate. Because you know, you are making a really good point. Is what if we build this and it turns out that all we get is the difference between 1.8 and 2 volts, right? What if that's what if that's the only 2 effective thresholds we get? Um, it might not be worth having the ability. It might be better just to add a header or a load switch to switch between. So it might. I think it is still going to be worth. I think it will be worth making a test board. So maybe that's what we'll do next week. Is we'll just make a quick test board, and then that way, while that board's getting fabricated, we can work on the rest of the board. Because if we have to get rid of this circuit later, then that's not a big deal. But I think at this point, I'm really curious to see how well this works. So I'm also tempted. Well, a rail-to-rail op amp is hard to find though. I'd be tempted to add an op amp and a bypass just in case we need. Well, no, the op amp won't do us any good. Never mind. Never mind. All right. Okay. I'm pretty happy with this so far. Yeah, I think the next step will be let's build a test board with this DAC and one of the buffers, and then test it out and see if one, it works the way we think it should work, and then two, let's find out, like Alex is saying, it may actually not do any good. Oh, I forgot I was going to add a OLED header. Huh. Okay. Let's add this down here. All right. Okay. When did I load Cortana? I don't even, if it's deprecated, then why is it even showing up? All right. Yeah. Okie dokie. I don't have any new content to share. So, yeah, I don't have anything to share for reasons. But what's the old joke? If you know, you know. So, all right. I don't see anyone doing STEM, so I'm not going to rate anyone on Twitch. So yeah, totally, completely forgot if you've started following today. Hello and welcome to the stream. I completely missed the what do you call it? The thingies. So whoops, my bad. Let's go to this, and then oh, I gotta figure out how to get that. I need to add that, don't I? Because that looks dumb right now. Okay. All right. Well, thanks for hanging out. Here's the thing. I started a new job on Monday, and so I don't know how that's going to affect my ability to stream and this in this same time slot. And also, we're getting into winter, which in the winter time, I do like to do streams on Sunday afternoons since I don't like to be outside when it's cold. So I plan to stream next week. I don't know for sure what day or time. So just keep an eye out for it. I'm going to do what I can. I definitely want to build this little test board we're talking about. So that's probably what we'll end up doing. Ah, Northern Lights. Oh, actually, that would be cool to go see. Unfortunately, I can't see it. I live right next to a big city. But if you can go outside and see it, then go check it out. Last time it was pretty cool. Let's keep in touch if you have ideas for the project. Here is the Discord, which is a legal requirement since I'm doing streams. So yeah, check it out. Let's keep in touch. And yeah, I'll see you guys later. Remember, find time to do something you enjoy. And if you do, please think about sharing it with other people. All right, take care. See you later. Bye.